This is my new homelab DNS server, Technitium. It's self-hosted, runs in Docker, gives you a clean web interface, local DNS zones, block lists, forwarding, recursion, and even advanced features like dynamic DNS updates, clustering, or DNS encryption. And the reason I think you should be running this too is quite simple. It's much more powerful than your stupid router DNS, but it's not nearly as complicated as other DNS servers we've already covered on this channel, like Bind9, for example. This is the DNS server I was using before. And Technitium even includes many of the features you usually only get from DNS blocking systems such as Pi-hole or Edgard Home, which I've also covered in previous videos. But many of you guys have recommended Technitium to me, and I can only agree with you guys. For me, it beats them all because it can be both. It can be a super damn simple solution if you just want DNS records in your home lab to resolve friendly service names to internal IP address and do some ad blocking, but it still gives you all of the advanced features to go deeper once your setup grows, or if you want to use this in a small or medium-sized company for managing DNS in a much better and easier way than most of the other big and huge DNS solutions out there. So let's check it out together. Before we do that though, let's also quickly talk about monitoring, because DNS is one of those services you only notice when something breaks. And in a professional IT environment, there are many other critical services just like that. And of course, you want to know what's going on. So that's where Op Manager Nexus, made by Manage Engine, the sponsor of today's video, comes in. Op Manager Nexus is an IT operations management and full stack observability platform that's being used by NetOps, DevOps, SRE, and IT teams that need full visibility across their entire infrastructure. And what I think makes this platform really interesting compared to other monitoring tools is that Op Manager Nexus brings a wide range of areas all together in one single platform, like it does application performance management, infrastructure monitoring, bandwidth and traffic management, configuration and compliance management, plus IP addresses, switch port and firewall management. And it supports more than 450 plus vendors, 10,000 plus device types, and 150 plus applications right out of the box. It's super powerful. And instead of having to stitch different sensors, metrics, and tools all together, you can get visibility about everything that matters in your infrastructure from one central place. Of course, it also does fault management. It can help you stay ahead of outages with root cause analysis, troubleshootings, reports, alarming, and adaptive thresholds that use machine learning and predictive algorithms. Op Manager Nexus is a really huge and solid professional platform. It has tons and tons of features, so more we could cover here. So better try it out yourself. There's a 30 days free trial that is super simple and easy to set up on a Linux or Windows server. Of course, you will find the link to it in the description box down below. Alright guys, so now let's get started with Technitium DNS server and let's set it up on one of my demo servers. Now, this is the official website. As you can see, it honestly isn't pretty, to say it bluntly. It's terrible. But anyways, it is functional for what it does. And it doesn't really seem to be such a large project, but it still has some impressive list of features, those that you typically would expect from a professional DNS server. It's also interesting to notice that Technitium DNS server is an open source authoritative as well as recursion DNS server, which works out of the box with no or minimal configuration. And it provides a super user-friendly interface where you can configure all the settings. And while most other solutions out there are usually based on the bigger DNS projects like Unbound or Bind, like many DNS servers on appliances or firewall systems, they just use these huge DNS servers that are battle-tested for decades under the hood, and they just put a nice web interface or config manager on top of this. Technitium is a completely independent project, and it has a super low footprint, so you can download and run this on any Linux operating system, Raspberry Pi with an automated installer. Of course, there's also Windows supported and macOS as well if you want to run a DNS server on macOS. But as you might know from most of my other video tutorials, my preferred way to install and set up such an application would be in Docker. So there is an official Docker image that we can use. And there is also a docker compose.yaml example file that includes most of the settings you can configure via environment variables, as well as a minimal, starting point. However, I've also written my own template to deploy a Technitium DNS server using Docker Compose and publish this for you on my Boilerplates library project on GitHub. You will also find a link to this in the description box down below. And together with my Boilerplate CLI, you can easily deploy these templates with minimal effort. I will link you this in the description box down below. I've also made a separate tutorial video on this, so might be worth watching. It's super simple. Just go to your project directory, execute the Boilerplates CLI program with a Boilerplates repo update command. This will pull down the latest changes from my Git library. Then you can get a list of all the templates that I have created and published here. For example, there you can see the Technitium DNS server. I've added some settings for pre-configuring this DNS server, as well as exposing ports, setting up network modes if you want to run this in network mode host or with a MAC VLAN bridge if you need a separate IP address for this container. But you can also use it with a traffic reverse proxy. You could easily set up trusted TLS certificates for this web interface. And this, by the way, can also be used in combination with DNS-over-HTTPS later. It will also be part of this video, so keep watching until the end if you don't want to miss that. And let's start generating a new compose file from this boilerplate template. I will just use most of the default values for the container hostname, service name, restart policy. I think we don't need to change that. Now here is the DNS domain. I will set it to demo.secrave.de because I'm already running a Technitium DNS server in my production home lab. I will show you that later. And here we can also set some variables like the recursion protection that is by default a low only for private networks. We will talk about recursion later in this video, so don't worry about it. Can also enable blocking. Let's do that. But don't worry if you're missing anything here. You can later always configure this through the web interface. Also want to enable DNS over HTTP because we need that later. And yes, use local time for logs. Okay, that's fine. The web console port you usually don't have to change, as well as the DNS over HTTP, HTTPS port, the DNS port. The network mode can be default, so then it will just use a normal Docker network. In the bridge mode, I will also use a local Docker volume, so a persistent volume for all the configuration files. You could also connect an NFS share or another mount point on your disk if you need. And now comes the interesting part for setting up trusted TLS certificates for DNS over HTTPS and for the web interface. So therefore, I want to enable my traffic reverse proxy. By the way, if you are not aware of traffic, you don't know what this is, I've also made videos about that, so check it out on my channel. And the host name I would set to DNS demo. I think that's fine. And the domain will be home.clcreative in my case. So I'm not using the same domain as for the DNS server later because, again, this is a domain that is existing. And I think, I almost forgot to add server test home.clcreative.de because I've added a wildcard DNS record that points anything in front of server test1 to the IP address of the test server where we later want to deploy Technitium so that I can directly reach this web interface through my secured reverse proxy traffic. Again, if you're not aware of this, just leave this off by default and just connect to the web interface port on port 5380. So that's the simple way to do this in your home lab. All right, but yeah, for those of you who are traffic fanboys, let's just continue this setup. Of course, I want to enable TLS with my Cloudflare DNS provider. And now I want to store or generate this boilerplate template or the compose file directly on my remote server. So then I don't need to copy it manually. So I'm just going to say server test1.home.clcreative.de, and the directory should be Technitium in my local user folder. I think that's fine. So let's hit enter and see, yep, boilerplates uploaded successfully. So we can log into the test server and see there should be a new directory here, Technitium, and here is the compose file as well as the .env file. So that env file contains the secret admin password. And yeah, so here you can see all the settings. I'm not exposing any of the web interface ports or the DNS over HTTPS port, just the normal DNS port 53 on TCP and UDP. There are the traffic labels. There's one service for the web interface and one service with the /DNS query suffix. This is for DNS over HTTP. We will later take a closer look how you can configure this. For now, let's just run this with a Docker Compose up-d. And if you want to see if everything was deployed successfully, you can also monitor the logs with the Docker Compose logs -follow. So then you should see when the DNS server has been deployed, when everything is ready. Of course, this is not the real URL because we're using traffic. We need to use dns-demo.server-test1, just what we had configured. It's all set up with trusted TLS certificates using my traffic reverse proxy, and I can easily log in with admin and by using the generated admin password here. So that's a web interface of Technitium. Again, nothing really special or too excited. It's a really simple but functional web interface, just like the website, by the way. But here you can go through all the different sections to configure your DNS zones, to configure the caching, blocks, apps. There are administrative settings where you can configure TSIG for dynamic updates, recursion, caching, blocking, forwarding, and stuff like that. And you can even enable DHCP if you want to use that. But honestly, I'm not a big fan of, running DHCP on a DNS server, but it is possible if you want. And of course, you can also create multiple users with different permissions groups and even single sign-on. So it is absolutely usable in a small to medium-sized company as well, as at least if you ask me. All right, so that's the installation or the setup of Technitium. Now let's talk about how you can actually use or configure this DNS server. I don't really know how familiar you are with configuring DNS servers in general or using this in a home lab. I try to split this into two sections. So the first one will be more beginner friendly, and later on we dive into some more advanced topics. So if you are already an advanced home lab user, you know what a DNS server is and how to configure it. You probably can skip this part if you want, but I thought it might be good to have a comprehensive tutorial that covers most of the practical use cases why you would want to use such an app in a home lab. The first and the very first thing you should do, or the main thing you will need, is to create a new primary DNS zone on this Technitium DNS server. So that means that the Technitium DNS server becomes the main DNS server for a specific zone. And a zone can be basically anything. It could be example.com. There are different strategies how to do this. Some people prefer something like a local or a home lab zone. For example, I own sealcrave.de or christianlemper.de. Anything in my home lab, for example, is having the home crave.de zone. So this way I can better separate my public from my private resources. So because this is already existing on my home lab, I want to use a separate zone like demo.sealcrave.de. And this is, of course, a primary zone. Just to quickly explain what the different types of zones are, the primary zone is that portion of the DNS name that is managed as a single administrative unit. Again, this thing here. And a secondary zone is a read-only copy of a zone that should not make any changes on its own, but it's just there as a backup. Then there's also a stub zone, not really important in my opinion, and a conditional forwarder zone that is not really the same as a zone, but it is more like a DNS configuration entry. So for example, if your Technitium server is the authoritative DNS server for any zone, but you have a separate zone that should be handled by a different server. So then you can make this Technitium DNS server your main one, but still configure or say, hey, this other zone should be handled by another server. If you have a simple home lab, no complicated configuration, just stick to the primary zone by default. You can also, by the way, import a zone file. So when you're migrating from another DNS server, like Pi-hole, AdGuard, or Bind9 or whatever, and you already have a zone configuration file, you can export that and import it in Technitium so that you don't have to manually add all your DNS records again. That's, of course, super convenient if you want to switch to Technitium from another DNS server. And you can also enable the zone serial number that always increases whenever you change a zone. That is useful to see when something changes. For example, if you have multiple clients that make updates to your DNS server, sometimes useful. So I'll just add that. And the cool thing about Technitium is that it already creates the primary DNS zone with meaningful entries. So everything that you need to operate this DNS server, such as a name server record that already is set to the demo.sealcrave.de, then an SOA record that contains the primary name server location as well as the responsible person, refresh intervals, retries, timeouts, something like this, yeah? And now you can start adding your DNS records. For example, I want another host like server test 2, for example, demo.sealcrave.de should be resolved to the IP address 10.20 10.21.2. And this is, of course, an A record. You can also add a reverse PTR record. Note, this requires to create a reverse zone for PTR. Normally, you resolve names to IP addresses, but sometimes you have an IP address and you want to know, hey, what is actually the DNS name? This is why you need a PTR, so that you can resolve the name or the IP address. By enabling this option here, this will generate the record here. But when you go back to the zones, you can also see a 1.20.10.in address rparse zone. This is the reverse lookup zone. And in here, you can find the entry server test2 demo.cgrave.de, but you can see that resolves the IP address 2 of that zone back to the name, so that it's like the other way around. And this you can enable with these checkboxes. But you also have to keep in mind, if you make changes to the IP addresses here, you also have to do it in the reverse lookup zone, yeah? Otherwise, you have a mismatch here and there. All right, so now let me just demonstrate what happens when you try to resolve the name. So we will use a simple CLI tool, then the IP address of the DNS server. Because my default DNS server on my Mac is set to my primary router DNS, I will have to specify the IP address of the server test1 where Technitium is running. And then I can resolve the server test2 demo.cgrave.de. That should come back with the IP address 10.21.2, so the one that I have just added in here. And you can also check the PTR, so with a -x, and also check if the reverse lookup also works. Here you can see a PTR of that IP address points to the same name, so that works perfectly. And just like that, you can now start adding all of your DNS records and whatever you need in your home lab, add all your machines, your services, applications, whatever. Again, just to show you a few records that might be useful. The PTR we've already covered. The DNS-A record, that's a simple name to IP address. Then we also have a CNAME. This is something like an alias. Yeah, if you want to add an alias to another name. Then there are AAA records. These are for IPv6 addresses. Honestly, guys, I avoid or try to avoid IPv6 in my home lab. So yeah, you can add many different types of record. Maybe a TXT record would also be useful. Sometimes you need that. All right. One thing that I also should explain if you're completely new to this topic, and you can see, all right, yeah, good. I can use a simple NS lookup or a simple CLI tool like dig to get the IP address of a service name. But how do I actually make my clients use Technitium as my primary DNS server? Because that's the main important thing. Otherwise, the DNS server is just sitting there and it doesn't do anything. So usually you configure this on the operating system. For example, here in the Ethernet configuration on macOS, you can set the DNS server here. There's an IP address. So this is the manual per device configuration. Again, just I showed you, you go into the network settings of your laptop, server, your phones, like every device, yeah, even the virtual machines, and configure it on the operating system. Sometimes there's also a browser that has its own configuration, like Chrome does like to enable DNS-over-HTTPS by default, resolve that on the Google's DNS server. So you might not only have to change that on the operating system itself, but also in some of the application, like a browser is usually the place that does its own thing here and there. This is super annoying because you have to do that on each single device. Super complicated and time consuming. Therefore, you should use one of the two other methods. The first one would be the DHCP provided configuration. Just like I showed you here in the settings on macOS, you probably have noticed that this is the IPv4 is configured by DHCP. But a DHCP server does not only just configure the IP address for the clients, you can also set specific DHCP options in your DHCP server settings that configure certain entries for the client as well. Like, where is the DNS server in this network? This, of course, you have to configure for each router or for each DHCP server in a different way. I can show you only this on my OpenSense firewall. So here, for example, when I go to services, IFC DHCP, I know this is a legacy one, but it's still the one that I've currently configured. Here you can create the IP ranges and stuff like that, but you can also configure DNS servers here. So just add the IP address of the server where Technitium is running here. And just like that, most of the other routers can be configured in the same way. So when the client sends a DHCP request, router will send the DNS server IP to the actual client, which is then the Technitium DNS server in your home lab. That has the advantage that it gets distributed on all the DHCP clients completely automatic. Just configure that once, and when a client asks for an IP address, it also gets the correct DNS server. Super practical. But there's also another configuration option. That is what I'm personally using in my network. You have one primary DNS server. In my case, this is not the Technitium DNS server. It is the OpenSense firewall. This is and it remains the primary DNS server. But I have added a query forwarding in the unbound DNS server here on the OpenSense firewall to set everything that resolves to home.clcrave.de should go to this IP address. And I could now just add another one for demo.clcrave.de that goes to 10.20.1.1. This has the advantage that your main router still becomes the primary DNS server, and it can use the resolving mechanism for all the other public stuff, like anything that goes to the web will be resolved via your existing DNS server. Only the internal zones or the zones that you want for your home lab will be resolved by the Technitium DNS server. And you can have your existing rules, your existing configurations in place, but it also has a disadvantage because then Technitium does not become the one and only DNS server in your network, and it is not the main controlling part, and you cannot use some of the features of the Technitium DNS server like recursion or blocking and stuff like that. So I'd say, even though I'm running this query forwarding setup now, I think I will switch to the second configuration method at some point in the future to take away the DNS resolving logic from my OpenSense firewall and really just use Technitium as the one and only DNS resolver in my network. I think that would be much better, because one of the advantages of the Technitium DNS server is that it does not only act as a simple query forwarder, so it doesn't take a DNS request and send this to, I don't know, Cloudflare or Google or whatever. It can also do its own DNS lookup using recursion. So this is what you can add in the setting. With recursion, the Technitium DNS server can act as a resolver itself. So it doesn't need to ask another DNS server, what is the IP address for, I don't know, website XYZ. It starts resolving everything on its own platform. Like, it starts asking the DNS root servers, hey, what is the top level domain DNS server for that domain, whatever. Then it goes to the TLD servers. Then it asks the authoritative DNS server for that specific domain. It caches the result and then returns the answer to the client. So it's basically doing the whole chain of DNS lookups. And that might sound like a trivial thing, but it is not. Most home routers or simple systems, appliances, they only act as a DNS forwarder or proxy. So they take the DNS request and forward them to Cloudflare or to Google. But with recursion, you can completely do that on your own self-hosted infrastructure without having to rely on Google's DNS servers. And that has the advantage that you are in complete control of everything, like the caching, the logs, the validation, your own DNS queries, which is great for privacy because you don't hand over all of your DNS requests to a third-party vendor or to your ISP. The only thing that you should keep in mind is that you should never, ever allow recursion on public or public-facing networks. This should only be allowed for private networks. Otherwise, other people can abuse your DNS server to do any DNS injection attacks, whatever. I'm honestly not an expert in this, but it is possible. So therefore, as an administrator, put this always behind your firewall. Make sure no one from external networks has access to this, and only allow recursion from private networks, which is the default. You could also add specific access control lists to further lock down the access. This is, of course, much more secure. And what you should also do, which is luckily also enabled by default, is caching, because otherwise, if you don't enable the DNS cache and you do recursion, Technitium needs to resolve every single DNS request all the time, and then it becomes slow and certainly inefficient. So DNS caching, this is super, super important. Anyways, if you don't want to deal with that, and you're just fine with hand over the DNS request to Cloudflare or to Google, you can still enable proxy and forwarders here. Choose any of the public forwarders like Google, Quad9, those are really good, and you can use the protocol, something like, I don't know, DNS-over-HTTPS to even encrypt these DNS requests, also pretty useful. So yeah, that's it about basic DNS functionality. I think if you are done with that, you have done your setup, you're already in a good shape. I think everything that comes later on is just, if you're interested in this, I still want to show you a few things that I thought might be useful. I've explained ad blocking via DNS records as well in my AdGuard and Pi-hole video. Technitium can also replace those as well. So similar to Pi-hole or AdGuard, it can block domains before browsers or even applications connect to them, which is not the same like a browser ad blocker, because this works for your entire network. Yeah? When you've made Technitium as your main and primary DNS server for all your devices, you can easily just go to settings, go to blocking, and add one of the blocklist URLs in here. Here in the quick add section, there are many pre-configured block lists that you can enable, such as the Steven blacklist. I think we've done that in Pi-hole as well. This includes specific blocking sets for adware and malware, but other no safe for work categories you might want to avoid in your network. Note, this is not an application blocking or anything like this. It is still not as reliable as a layer 7 blocking or something like this, but it is the first layer of defense. A DNS lookup is really the very first step that someone needs to go to a website. So if you add protection at this level, it is really a super efficient and simple way to get rid of most of the annoying adware and malware and non-safe for work categories. So I don't have a recommendation here what to use. I just have made good experience with the Hagesi multi-normal all-round protection. So if you add that, it just adds the simple TXT record in here. The only recommendation I can give you here is don't add as many lists as possible, because you think, oh, then I get the best protection. Yeah. So start with one that you think is the right data set for your needs, and then only if you have trouble with that or you want to experiment, add another one or maybe switch that or so, but please don't add all of the lists in here because you think that would be the best choice. Yeah, so when you have done that, you can save the settings, and I can just demonstrate this to you because this should mostly block things like, for example, I don't know, Google Analytics. So then if we do a DNS lookup, you can also see we don't get a result back, and there you can also see the list. The source is blocklist zone, the blocklist URL is this one, so then you also can see what specific list triggered what lookup. And of course, you can also get all of the metrics and statistics in the dashboard. So here, for example, there's one query that got blocked today. The next thing that might be a little more advanced, but I still think it is worth showing to you, is the dynamic DNS updates via TSIG. So this is a shared secret for DNS updates. Just imagine like this. You have a DNS zone and you don't want to manually add all the records yourself in the admin interface. You want to use infrastructure as code tools like Terraform, for example, to automatically provision your virtual machines or your applications, and they need DNS records. Then you can use the same kind of process to automatically create a DNS record without you having to do this manually all the time. And you can manage this in infrastructure as code lifecycle, which is super useful for DevOps processes, automations, and stuff like that. I've already done a video on TSIG in my Bind 9 tutorial, so I will link this to you in the description because I won't go through each and everything. If you want to know more details about that, then check out the other video. Just skip the part with the Bind 9 setup and straight go to the TSIG part, and then you can return here, and it's basically configured and used the exact same way. You add a TSIG record here, you add a key name, TSIG, homelab or whatever, then put in a shared secret or let this be generated by Technitium automatically. So if you leave this empty, save the settings, this is a shared secret that is for whatever reason visible here in clear text. I don't know why. Yeah, just copy this. Keep it secure, and then you also have to allow dynamic updates on your DNS zone. So select your primary DNS zone and go to Options, Zone Options. Then you can allow dynamic updates. One thing that is important, if you don't enable the TSIG key here in this menu, it will allow everyone to perform dynamic updates, which is not safe. So therefore, only when you allow this, make sure to add a TSIG security policy here. Click on Add. Your TSIG key that you have created earlier should be visible in here for that domain name, and you can also only allow specific record types like AAAA, maybe you want to allow MX, whatever, and click on Save. So now the options were saved, and we can start adding this in my Terraform projects. So here, for example, is my Terraform project, and here I have added a DNS record for my home DNS servers. I think that's actually the DNS record for my production Technitium server. So that resolves dns.home.cgrave.de to that IP address. And then in the provider settings, I have added the DNS provider HashiCorp/DNS in that version. Here's my secret variable for the TSIG record. And in the provider settings, I configure the server name, the key name. So this needs to always match the key name that you created here. And of course, the algorithm needs to match and the key secret as well. And then you can start managing DNS records. And here, if I need a new DNS record, I can just copy and paste this DNS record 2, for example, to a different IP address. Or I simply can use AI to say, hey, can you create me new DNS records? And it automatically does that for me. Super, super practical. All right, so the next thing that I want to show you is encrypted DNS. Because I've just covered this in my AdGuard Home video, I honestly thought AdGuard Home would be just amazing for that, but actually I found out you can easily do this in Technitium as well. So you just need to go to Settings, you go to Optional Protocols and enable DNS over HTTP. Now, why do I do this? DNS over HTTP and not DNS over HTTPS? Well, that depends on if you're running this behind a reverse proxy or if you're using no reverse proxy and you just exposed the 443 port of Technitium, then you need to use a certificate. So create a self-signed certificate and upload this to all your clients, or use Let's Encrypt or any third bot, whatever. I think this is super, super annoying. So therefore, I always use reverse proxies like Traffic to own the certificate resolving process. Much, much easier. But of course, the Traffic reverse proxy will not forward this to the internals HTTPS server. It will use the HTTP server instead. So if we take another look at the Docker Compose file, so here is the Technitium DNS over HTTPS route. And of course, you also need that here, optional protocols enable true, or you enable this setting here. And then you should be able to do a simple lookup. And here you also need to use the same domain or the same address as you would use to connect to the web interface, of course, /DNS query. And then you can query for anything like, for example, let's query for server test. Did we add server test 1 or server test 2? Ah, yeah, okay. Server test2.demo.cgrave.de. I forgot one setting here, because here, if we're using a reverse proxy like Traffic, we need to allow the reverse proxy the queries or forward the queries. You could just add 000 if you're lazy, or you can add the internals Docker network to it. Let's inspect Docker Technitium. So it's using this here, 172.18. I think you can just add this here. And that should allow any requests coming from any of the other Docker containers as well. And let's try again. Now we get back the result. Here you can see, yep, that name resolved to that IP address using the HTTPS DNS over HTTPS query. Awesome. So yeah, that's it. Again, I've tried to make this a little faster because I assume most people interested in these settings like TSIG, DNS over HTTPS or ad blocking, you know, guys, what you're doing. If not, you can watch my other video tutorials. I've covered DNS over HTTPS in my AdGuard video. I've covered TSIG in more detail in my Bind 9 video. You'll find them in the description. Just to summarize, I'm really excited about Technitium, and honestly, I should have listened to you guys much earlier because I was just using Bind 9 and fiddling around with console configurations, and I was playing around with Pi-hole Ed got home, and yeah, finally I've switched to Technitium, which probably I should have used in the first place. But anyways, it was quite a journey. I could learn more about all these different solutions, and I can better understand where are the advantages, where are the disadvantages, and I can really say Technitium is by far the best one that I've tried out because it really fits a nice sweet spot here. You can easily run it in Docker. It has a simple web UI. You can create local DNS zones, records, enable block lists, and you're done. But at the same time, when you're getting more comfortable in your home lab, explore some advanced features like dynamic updates or DNS-over-HTTPS, or maybe experiment with secondary zones, clustering. Yeah, for example, this is something that I have not yet done, but maybe I'll do in future videos. But here I think Technitium is the perfect middle ground, and it even might be useful for a small to medium-sized company. Again, there are still a few things that we need to explore. If you're interested in this, please leave me some comments. What is your favorite DNS server? But please don't recommend another app to me. So I'm really just happy with Technitium. Just joking. If you want to see another DNS server, I might review it as well. I'm really happy for any feedback from you guys. And that's really it for today. Thank you so much for watching. Don't forget to give this one a thumbs up and subscribe to the channel if you want to see more self-hosted and home lab videos. And of course, I'm going to catch you in the next one. Take care. Bye-bye.